Okay, so this is the third lesson in our partial fractions set of lessons, and in this case we have to look at improper fractions. Now I'm going to come on to improper algebraic fractions in a second, but before we do that I just really want to recap something that we probably did in about year 7 or year 8, and that is thinking about what an improper fraction is. And as I know you are well aware, it's when the numerator is bigger than the denominator. So an improper fraction might be something like 20 over 3 or 20 thirds. Now, before we go on to the algebraic versions, I want us to think about what this means. And that is equivalent to saying 20 divided by 3. And again, I want to think back to probably primary school now. If we did 20 divided by 3, we would say that 20 divided by 3 is 6, because there's 6 lots of 3 in 20. And again, really going back to primary school, you say we'd almost have gone 6 remainder 2. And I want us to think about what that means. It means there's 6 lots of 3 in 20, but we've still got 2 to be divided by 3. And this was one of our ways that we turned improper fractions into mixed numbers. But again, what it means is there's 6 lots of 3 in 20, but we've got 2 left over, but that 2 still needs to be divided by 3. And we can have exactly the same situation in algebraic fractions. But what makes an improper fraction when we've got algebraic fractions? And I'm going to give you a couple of examples, and I'm going to see if you can decide what will make an improper fraction. So these are going to be improper on this side, and on the other side we're going to have not improper fractions or proper fractions. Okay, so an example like this: x squared plus 3x plus 2 divided by x plus 2. That's an improper fraction. If I'd written that the other way round, that would not be an improper fraction. Okay. If I had x to the power 4 plus x minus 5 over x squared plus 3x plus 5, again, that's an improper fraction, whereas the other way round it wouldn't be. If I had x to the power 7 plus 2 divided by x to the power 5 plus 3, that would be improper. Whereas if I had x to the power 7 plus 2 divided by x to the power 8 plus 3, that's not improper. And it all comes down to the highest power of x. Just like with a non-algebraic fraction, we need the numerator to be bigger than the denominator. In algebraic fractions, it's slightly different, but we need the highest power of x in the numerator to be as big or bigger than the highest power of x in the denominator. Okay, so an improper fraction occurs when the degree of the polynomial in the numerator, okay, is greater than or equal to the degree of the polynomial in the denominator. Okay, so we could have the same degree. So another one that is an improper fraction would be something like x squared plus 3x plus 5 over x squared minus 1. That would be an improper fraction. Okay. Now, before we actually go on to the main purpose of this lesson, I also need to recap something else. And this is a bit of a reminder about polynomial division. And I'm going to do one that we would have done last year, and hopefully really quick recap. And if I'd have had to have done 10x cubed plus 27x squared plus 14x minus 6 divided by 2x plus 3, if you remember, we use the reverse grid method because we want to know what multiplied by 2x plus 3 makes our 10x cubed plus 27x squared and so on. Okay, and like I said, we use our reverse grid method. So we started like this and we said, well, we need 10x cubes. So we write the 10x cubes there. What times 2x makes 10x cubed is 5x squared. And then we fill in that column. So we've got 10x cubed and 15x squared. And at that point, this was here. So that's perfect. Now, the 27x squared has to come from these two diagonal components. So because I've already got 15x squared, I need another 12x squareds. So 2x times what makes 12x squareds was 6x. And again, now fill in this column. 6x times 3 is 18x. And then we go, these two elements are going to make my 14x. I've already got 18x, but I only want 14. So actually I've got to take 4x's away. And then what times 2x makes minus 4x? So that would be minus 2. You go minus 2 times 3 makes minus 6. And if you remember, that was our check value. If we knew this was a factor of this. Okay, so this divides into this wholly. Okay. Now, a slightly more complicated one is when we start increasing the degree of the polynomial. But it's exactly the same process. I am going to think something times x squared plus 3x plus 2 makes my x to the power 4 plus 3x cubed and so on. So, first step, I have to do my first term, which is x to the power 4. So x to the power 4 goes in the top left-hand corner. What times x squared makes x to the power 4 is x squared, and then we fill in the column. So we've got 3x cubed and 2x squared. Right, so that term came from there. Now again, we think about these diagonals. So my 3x cubed got to come from this point and this point here. Now I've already got 3x cubed, so you might be thinking, I haven't got a clue what to put in that other place. Well, effectively, I want no x cubed as well. And sometimes these sort of things happen. You do end up with 0 of something, and it's always a good idea to write it in. So, what times x squared makes no x cubes? Well, it's going to have to be no x's. And again, fill in the column, and you end up with this. Now, this is where it starts going a bit more complicated to anything that we've done before. Because now we need to look at the x squared term. I need minus 5x squared. But this is going to come from 3 places. Okay, from this bit, and this bit. I've already got 2x squared, but I want minus 5x squared. So that means I need minus 7x squared there. So, what times x squared makes minus 7x squared? I've got minus 7. Fill in the column, minus 21x, minus 14. And actually in this situation, I've got 2 checkpoints to see if I've got the right answer. Assuming that x squared plus 3x plus 2 divides wholly into that original polynomial. Okay, so they take a bit more practice, but they're not too bad. But with an improper algebraic fraction, we're going to have a remainder. So this is the bit that's brand new now. But we follow the same process to begin with. Okay, so again, I'm going to do my reverse grid method. Something times x squared plus 2x minus 3 is going to make 2x to the power 4 minus 3x cubed minus 7x squared and so on. And again, follow the same process. So my first term is going to come from my very top left corner. So I'm going to have 2x to the power 4 there. What times x squared makes this? Well, it's got to be 2x squared. Fill in the column. 2x squared times 2x is 4x cubed. And 2x squared times minus 3 is minus 6x squared. Right, got to deal with the x to the power 3 term. So remember, these always come in diagonals. Now, I've got 4x cubes, but I only want minus 1x cubed. So I need a minus 5x cubes. So that's going to be minus 5x on the top. fill in the column, minus 10x squared, and minus 5x times minus 3 is plus 15x. Now this is the bit that is again different. We've got to think these diagonals now make the minus 7x squared. So I've got minus 16x squared here, but I only want minus 7x squared. So I need to have a 9x squared. Fill in the column, because that's got to be a 9. So I'm going to have an 18x and a minus 27. And this is where the checks no longer work, because that is an 18x and that isn't minus 21. Okay. And this is where we actually then have a remainder, because we can make it work, but we can only make it work if we have a remainder. So these all have to make 26x. Currently, I have got 33x, so that needs to be minus 7x. I then look for the next diagonal, and these have to make minus 21. So I've currently got minus 27, so I need to add 6. Okay? And that becomes my remainder. So my answer to that big polynomial divided by that quadratic is written like this. My answer is 2x squared minus 5x plus 9 with, you could say, minus 7x plus 6 as my remainder. But going back now, I'll flick right back. What did I do with my remainder when it was just a normal fraction? I said my remainder still had to be divided by that 3. And the same is true with algebraic fractions. What we say is we've still got the remainder, which is minus 7x plus 6, which still needs to be divided by my x squared plus 2x minus 3. Okay. Now, sometimes don't like writing that minus 7x plus 6. You might write 6 minus 7x, okay? But it's just writing it a different way round. Doesn't matter. So, if we have a remainder, that remainder still needs to be divided by whatever was in the denominator. So let's go back to our partial fractions. So here we go. We've got an improper fraction. How do we know it's improper? Because they are both degree of order 2. In other words, they're both quadratics. So that means it's an improper fraction. And so that means we have to do the division first. We have to do the polynomial division first to work out what this number here is, what this letter A is. So do my grid method. X squared minus 3x plus 2 multiplied by something makes 3x squared plus 2x minus 1. So let's get my highlighters. So first one, I want my 3x squared comes from that top corner. So there's my 3x squared. What times x squared makes 3x squared is 3. Fill in the column. 3 times minus 3x is minus 9x. And we've got 6. Now, this, a different colour, my 2x comes from these two lines here. So I fill it in. Minus 9x and what makes 2 must be 11x. And this is where you know this must be the remainder part, because nothing in this situation multiplied by x squared can make 11x, because we can only have positive powers of x at this point. Okay, and I look at my final bit. I need my 6 and the number in my remainder to make minus 1, so that must be minus 7. So once I've done my division, I can actually say this equals 3 plus I've still got my remainder, which needs to be divided by x squared minus 3x plus 2. And it's now at this point that I do my partial fractions on this, because I've no longer got an improper fraction. The degree of the polynomial of the numerator is 1, which is less than the degree of the polynomial of the denominator. So what I actually have to do now is I have to do my partial fractions on the remainder. And if we factorise that, we can write that as x and a 2 and an x and a 1, and it's going to be minus 2 and minus 1. So I can write 11x minus 7 over x squared minus 3x plus 2 is a over x minus 2 plus b over x minus 1. Back to normal partial fractions. These are usually a little bit easier than the repeated ones that we've done, so these can usually get done quite quickly. So remember, got to make the denominators the same, and I end up with 11x minus 7 is equal to a times x minus 1 plus b times x minus 2. Do the substitutions. Do x equals 1 first. 11 minus 7 is a times 0 plus b 1 minus 2. So I've got 4 is equal to minus b. So b is equal to minus 4. Then I'm going to substitute x equals 2. So I've got 11 lots of 2 minus 7 is equal to a 2 minus 1 plus b. Well, that gets to be 0. 22 minus 7 is 15, mind blank. So I've got 15 equals a. So a equals 15. So my final answer to my original question, which is up here, is 3 plus 15 over x minus 2 minus 4 over x minus 1. Okay. Right, do one more example. Again, just trying to put it up a little bit harder. So, sometimes you don't always realise you've got an improper fraction. So the first thing you've always got to do with any of these is think, what is the degree of the polynomial in the numerator and the denominator? And in this case, I've got a degree of 3 in the numerator. It's not that obvious what I've got in the denominator, but actually you can see it's going to be an x squared in the denominator, so it's an improper fraction. And if I expand my denominator, I've actually got x squared minus 1. So I need to do 4x cubed plus 3x squared minus 2 divided by x squared minus 1. Now this is where it gets a bit funny sometimes, because this is what I want to do, x squared minus 1. And I notice in both cases I've got no x's in there. But it's always a really good idea when you're doing polynomial division to actually write it as no x's minus 2 divided by x squared plus no x's minus 1. And actually write every term in, okay? Because then when you do your division, you're not accidentally going to do anything and everything lays out in the correct diagonals. If you don't, this doesn't work, okay? So our 4x cubed comes from this top corner here, so our 4x cubed goes in there. So what times x squared makes 4x cubed is 4x. Fill in the column. No x squared, because 4x times no x is no x squared, and minus 4x. Right, let's think about the next diagonal. So the next diagonal is going to give me my 3x squareds. I've got no x squareds, so guess what? I need 3x squareds in there. So it's going to be multiplied by 3. 3 times no x still gives me no x, and 3 times minus 1 gives me minus 3. Let's look at the next diagonal now. So this next diagonal needs to give me no x's. Now currently I've got minus 4x's in total there. So I need a 4x in that top right corner to give me no x's. Okay. And then I think I also need to think about the fact that I'm on my remainder part now. So I need my minus 2. Currently I've got minus 3. So what do I need? I need a plus 1. And that becomes my remainder. So what do I have at this moment in time? I have got all of that is equal to 4x plus 3 with my remainder of 4x plus 1 still to be divided by my x plus 1 and my x minus 1. Okay, so I've got the polynomial division but with the remainder that still needs to be divided. And now I go back to doing my partial fractions on here. So hopefully I'll be able to fit this in. 4x plus 1 over x plus 1 times x minus 1 is going to be a over x plus 1 plus b over x minus 1. Okay, so my 4x plus 1 is going to be equal to a times x minus 1 plus b times x plus 1. What substitutions am I going to use? I'm going to say let x equal 1. 5 is equal to a times 0 plus 2b. So my b is going to be 5 over 2. Do my substitution, of x equals minus 1. And 4 lots of minus 1 plus 1 is going to give me minus 3 is equal to a times minus 2 plus b times 0. So my a is going to be 3 over 2. So back to this. My polynomial, my partial fractions are going to be 3 over 2x plus 1, substituting in the a, plus 5 over 2x minus 1. And that's the nicest way of writing that. So what's my final answer to my original question? I've got 4x cubed plus 3x squared minus 2 all over x plus 1 times x minus 1. And if we look up here, it was, when I did the division, I got 4x plus 3. But I still had to do my remainder. And when I did the partial fractions on my remainder, I got 3 over 2 x plus 1 plus 5 over 2 x minus 1. And so that's the answer. Okay, so if I recap these, if you have an improper fraction, the first bit you have to do is you have to do your polynomial division. Okay, and remember to put those 0 x's in and things like that. If you haven't got a term, if you haven't got an x squared term, make sure you put a 0x squared in. Okay, if you haven't got an x to the power 3 term, make sure when you're doing the division you write 0x cubed. So then the diagonals all work. Once you've done that, you've still got your remainder, which needs to be divided by your denominator. And that's where the partial fractions comes in. And then don't forget, you must make sure you write out your final answer. Okay? Right, so that's today's lesson. But I've got 4 for you to do. So have a quick go. Press pause. And I will then show you the solutions. Okay, so here we go. Question 1. It is improper because the degrees of the two polynomials are the same, so we've got to do that division first. It's quite straightforward division. So you end up with 6 plus, the remainder is minus 8x plus 5, but I've written that as 5 minus 8x in my numerator. Okay, got to do then the partial fractions on the 5 minus 8x over 3x minus 1 and x plus 2. You end up with those two values using those two substitutions. And so your final answer should be 6 plus 1 over x plus 2 minus 3 over 3x minus 1. Right, number 2. Again, you've got a quadratic over a quadratic, so it's a fairly straightforward division. Okay. And the remainder that you should have got was minus 7x minus 1. Now, I must admit, I do tend to write this like this, where I'd still leave it as an add, and I just make my numerator wherever it needs to be. Because then, when you come to do your partial fractions, you can just write what it is. If you wrote that as a minus at that point, things might just start getting a bit messed up, so it's better not to. Do the partial fractions. You should have got a is minus 2 and b is minus 3. And you end up with 2 take away 2 over x plus 1, take away 3 over 2x minus 1. Right, number 3, a little bit more trickier this one because of the fact that you've got this cubic over this quadratic. So your remainder is going to be a little bit more complicated to work out. You're going to have more columns to go, okay? But hopefully you got the same division as I got. So you ended up with that divided by that is 2x plus 3 with a remainder of minus x minus 7. So that remainder still needs to be divided. Do the partial fractions on minus x minus 7 over x plus 3 and x minus 1. And then hopefully you got a similar answer or the same answer as me. And then the final one, again, slightly more complicated, just because of the fact numbers are a bit bigger for a start. And you've got a cubic over a quadratic. Same sort of thing though. Again, I just wrote my remainder as 8 minus x rather than minus x plus 8, but doesn't matter. Partial fractions on that. Numbers weren't nice on this, but sometimes they're not. Okay. And it's nice for me to show you how I would write a b as of minus 10 over 7. And the way I would write it is minus 10 over 7. So that's the way I would put it in there. So you end up with 3x minus 12 plus 23 over 7 brackets 3x minus 1 minus 10 over 7 brackets x plus 2. Okay, so hopefully that's it for today's lesson. It's a bit of a shorter lesson, but probably quite a lot for you to think about. And I will see you next time.